Okay, so we've got two equations here. By the way, what I'm going to do is I'm going to label it equation 1 and equation 2. Now, 6x's plus a y is equal to 18. Now, the second equation is, as I think you said, Toby, less x's. I've got, how many less x's are there? 2. All right? And the value of the whole thing has gone down, hasn't it?
Is it how many it loses by there?
Okay. So you can make the connection that if I take away some x's, taking away some x's has affected the answer, yeah?
Aye.
Make sense?
Yeah, sense.
Makes sense. So how many x's have I taken away? 2 x's. And what's the answer changed by?
4.
4. So what conclusion can I make?
Combine the y.
You've just said it. If the left-hand side, I can call it the left-hand side, and the right-hand side, if I have taken 2 x's away from the left-hand side, and I've taken 4 away from the right-hand side, what conclusion can I draw?
Goes down by 4.
Well, what caused the answer to go down by 4?
Minus 2.
Minusing 2 x's. So can I draw a conclusion that there is a link between the 2 x's and the 4? So in this case, I can say that 2 x's must have equaled 4.
And what? Yeah.
Which means x must have equaled 2. Okay? Now, because we're writing notes here, we're going to formalise this a little bit. Does that make sense, by the way? What I said to everyone?
Yeah.
Yeah? So whatever I did, I looked at what I did to the left-hand side. I took 2 x's away. You could look at it the other direction if you like. From 2 to 1, I added 2 x's, and the answer went up by 4. All right? However you want to look at it. But what we have just done is we have done something called an elimination method. I don't think so. It does seem to pick up a little bit. Picks up enough. We've done an elimination method. Now, what does that word elimination mean? Not in this context, just but in general.
Remove.
Remove. So if you eliminate something, you remove it from whatever it is. So what have I eliminated here? Well, what I've eliminated is the need to think about the y. So by saying, I've gone from this set of information down to, well, 2x must have equaled 4. That gives me an equation that only includes the x. So what did I eliminate from the whole process? What did I eliminate? What's gone from the initial equation? What's gone from here? The y. The y is no longer part of the equation, right? By looking at the change, what has happened? Okay? By looking at the change, I'm going to try this bit. Yeah, so I've looked at this. I've looked at that and I've gone, well, what changed? And I've written a new equation, which is just, well, that's the change that happened. And looking at the change means I've eliminated one of the variables. Right? Now 2x equals 4, well, that's all it is. So a way to use the elimination method formally is to, so I've got 6x plus y, so you can write this down, is equal to 18. The second equation is 4x's plus y is equal to 14. How do I work out the change in something? Well, I'm going to do equation number 1 subtract equation number 2? Because that's the difference, yeah? Difference is subtraction, right? What's 6x? Take away the 4x.
Yeah.
2 x's. But what's y? Minus y is 0. And then I've got, what's 18 take away 14? It's the 4. So now with the equal sign back in there, look. So 2x plus 0 must equal 4, which is what we had before. And we get, therefore, x must equal 2. How do we work out what the y there? Yes, go on.
You have to place the 2 in the x of the equation that is the...
Exactly. So to work out the y, we use x equals 2 that we got from here. So which one do I use it in?
In the second one, because it's the lower.
Is that a have to, or is it just that makes sense?
Sorry?
Is that a I have to use the lower one, or just it's easier?
It's easier. It's easier.
Yeah, I could do either of them I want, but Alvaro is suggesting if I put x, it's just going to be smaller numbers, easier to do. So I'm going to do 4 times 2 instead of x, plus y equals 14. So 8 plus y is 14. So what does y need to be? 6. So that's my solving my simultaneous equation. What does that word simultaneous mean?
Multiple.
If things happen, okay, actually it doesn't mean one after the other. If things happen simultaneously, it actually means
No.
at the same time. So simultaneous equations is when you've got 2 equations that use the same x and y in different equations, but you're working that at the same time. Okay. So the fundamentals is we do have this method. You will see elimination method all over the internet and textbooks and things. But basically, what we're trying to do, AJ, is think what change is happening and can we relate the change to just one variable rather than another. All right. So you've got loads of questions there now. Let's pick another one to do. All right. So let's have a look at B together. Let's have a look then. So, what do we do? All right, so we've got 2 equations. We're looking for the change. All right, so which variable has the change in it? So if we formalize that approach, we can see that I've lost x's and that's made the answer go down. So if we use the formal approach, what we're going to do, I'm going to say, what's the difference between equation 1 and equation 2? 4x subtract x is 3x's. The 2y subtract the 2y is 0. 10 subtract 7 is 3. So I know the change or the difference between these two is 3x's, and that caused a change of 3. Therefore, 1x must be equal to 1. Okay. Now we're going to substitute that in. Which equation would you use, Angus? Which one would you choose to use? Which one would you choose then? Second one, okay? So we're going to use number 2. That's why I have 1s and 2s. Keeps it very clear what I'm doing. So I'm going to say use x equals 1, so then 1 plus 2y is equal to 7. Excuse me, because x is 1 now. What does that make? 2y has to equal 6, therefore 1y has to equal 3. Okay? So what I'm going to do now, guys, I'm going to take you back to the beginning here, look. So on the front of your page, we've got equations written, but we're actually doing, what's it called again? So we're doing simultaneous equations. Yeah.
Use
try.
decimals in the thing.
Yeah. There is something slightly different about this one. What's that?
It's equal to 1.
It's not just that it's negative numbers, but you'll notice in the other one, the focus is on the negative, but this is 9x minus 4y, but this is 4x plus 4y. So the change is not just in the x, it's also in the y, which kind of makes it more challenging, but we can deal with that. And I did give you sort of an example early on how we can deal with that, but any ideas what you could do? No ideas? Okay. So, go.
Or, it's
I'll
5x.
pause. Okay. So you're saying because we've dropped down 5x, the answer's gone up 1. All right, but there's a problem with that, which is it's not just 5x changing, this has changed as well. Okay? Okay, so what we're going to look at is the fact that we need to set it up so that one of the variables is not changing. So this is where I introduce you to changing one of the equations before we do with it. Okay? So I am going to, in this case, and maybe you can tell me why, I'm going to do equation number 2 and I'm going to multiply it by -1.
So they're both negative.
Good. So equation number 1, and I always do this, by the way, I always rewrite everything out. So equation number 1 is still 9x minus 4y equals 19. But what's equation number 2 now? Well, if I multiply everything by -1, I make that minus, this becomes a minus, this becomes a minus. So I've then got minus 4x minus 4y equals -20. All right. So my computer's struggling with all the things running at the same time. So, Toby, do you see how now that's a little bit different?
Yeah, it's easier.
It is a lot easier, isn't it?
I don't know.
Yeah. So what's the change then? So we're actually going to do equation number 1 subtract equation number 2. Okay? Because if I subtract the same thing, what does it become?
Positive.
So -4y subtract -4y becomes 0. That's why it's important they're the same. All right? So if I subtract, then I've got 9x's subtract, but this time it's -4y. What does that equal? 13y's. Now, does that make sense? Because actually, from -4 up to 9x, we are adding 13x. And by the way, that shouldn't be a y, should it? I don't know what I've done there. You should point that out. Ask that question. It should be x. 13. Does that make sense? Yeah. So from -4 up to 9, I've added 13x's. I've done nothing to the y. What do I do to the this. So if I do 19 subtract negative 20, I get the answer 39. So negative 20 up to 19 is add 39. So adding 13 x's added 39 to the answer. So what must 1x have been? 3. Okay. How do I find what y is?
Put it in the 9 bracket.
So use x. Oh, come on, computer. That's not me. So use x equals 3 in number 1.
Sure.
Okay. So 9 times 3 minus 4y's should equal 19. So 9 times 3 is
27.
27, good. 27 subtract what equals 19?
8.
8. Therefore, 4y's has to equal
8.
8, which means 1y has to equal
2.
2. So my solution is x equals 3, y equals 2, if I write my equation clearly. So the difference here is we had to make a variable the same in each equation. This one I don't need to change.
They're both positive.
Okay.
But you change like D because it's a negative.
Yeah, good. So should we go through this maybe with a highlighter now? So because they are the same, we don't need to change. These ones, they're the same. These ones though, everything's different. So that's the one we just did, so we had to change. What about D? Do I have to change one or not change? Change. What about E? Stay the same because we've got both minuses. What about F? Stay the same. What about G?
The same.
Because?
Positive.
No, not because it's positive. Good, that's the thing. It's because the 8x's. So this one would be a slight change because these ones we've eliminated the y value. But this one we're going to eliminate the x value first. What about this one?
The same.
We're going to eliminate the x. This one,
The same.
stay the same. This one,
Change. Would you leave it because they're 2
because exactly the x's are the same. What about k?
The same.
Stay the same. What about this one?
The same.
X's. This one. So this one has to change because you've got y's that are the same number but they're different ones. What about this one?
The same.
They're staying the same. This one?
The same.
So all of these ones that we had to change, it's because the plus and the minus, yeah? We did this one because it's a plus and a minus. All of these agree. This one's a plus and a minus. And then there's a couple more afterwards. But it doesn't have to be just on the y's. And it does get another level kind of a bit trickier, but you should be able to do it. Well, let's talk through this then. So I'm just going to label them equation 1 and equation 2, just because that's a good habit. Eh? Exactly, yeah. So what we do is we look at it and say, are any of the variables exactly the same? Well, we've got a y and a y, which is a positive start. But the problem is that we've actually got a positive y and a negative y. So we are actually going to have to do something about it. The x's are also different. We check the x's. So what do we do if they're the same number of y's, but one's positive, one negative? What do we decide?
Times by -1.
Times by -1. Which one?
The positive.
Could I do the negative on this one?
Because it makes it a positive.
Yeah, I could do it on either one I like. Which one would you like to do it on, Angus? You choose then. Do it on question 2. So let's multiply through by -1. That gives me equation 1 is still 2x plus y is 36. What's my new equation 2? If I've multiplied through by -1, it becomes minus x. This becomes plus y equals -9. So all of them change sign. Okay, remember then we're going to do an elimination. So this doesn't matter which order it is actually, but I'm going to do this lot, take away that lot to do the find the difference. Say it again. Yeah. So what do we get when we subtract? Well, obviously this bit becomes 0. So y subtract y. That bit becomes 0, so we've eliminated that. What about 2x subtract negative x? So 2x subtract negative x is? Subtract negative x. Well, if you subtract a negative, you get a addition, so that becomes
Positive.
so 2x plus x is 3x's, so 3x plus 0, so we can forget about the 0, but now we've got obviously 36 subtract -9, so 36 subtract -9, well that's the same as 36 plus 9, which is
One.
36 plus 9 is
45.
45. So now the result is we've eliminated the y, and now we've got an equation which is just 3x has to equal 45. If that's the case, 1x has to equal
15.
15. And then we're going to use x equals 15 in equation over to you. Which equation should we use? 1, 2, or new 2? Shouldn't matter. Equation 1. So we've got 2 times, notice how I'm putting it all in, so I'm doing all my communication, plus y has to equal 36. Slow. Therefore, 30 plus y is 36, which means y must be 6. So we've got our solution, which is x equals 15, y equals 6. So I should always make it clear what my answer is, because people end up kind of writing all over the place. So a nice clear box with your 2 solutions in next to each other is really important. So just checking, we've got 15 and 6. We used equation 1, so we know that 15 and 6 works with that one. But if I'd made a mistake with the x is 15, I would have still got a number for y, no problem, but it wouldn't work in this one. So we should just check that it works in equation 2 as well. So we've got 15 minus 9. That does, sorry, it's not minus 9, is it? It's 15 subtract 6 should equal 9, and it does. So both of those numbers work in both of those. Now, you can do that check mentally. You don't have to write it out, but it's worth doing. All right. Now, just before you go, what we'll do is next lesson we will look at what happens when we change it up a little bit. In equation 2, you'll notice nothing's the same. So we've got an extra step. Alvaro's going to teach us how to do that.